Good evening everyone, good evening. I welcome you all again to your Vedantu and NEET channel. I hope all of you are doing great, having a good time. So, my dear people, my dear NLEETs, just quickly let me know in the chats if I'm perfectly audible and visible to everyone. Yes. Let me quickly know in the chats if I'm perfectly audible and visible to everyone. Hello Mukaddas, hi Jai Krishna, hello Ayan, hello Ashwa, hello Nandani, good evening, hello Hyper Infinite Gamer, hello Ashwarya. Welcome back everyone, welcome back. Welcome back. Just give me a second, my dear people. Just give me a second, let me fix the things, we'll be starting, yeah? Just give me a second. Alright, so I welcome you all again to your Vedantu and NEET channel, hoping that you all are doing good. So people, what all things we are going to cover in the tonight's session, let me quickly tell you, this is going to be one more 0-2 superhero session from the chapter mole concept, right? So basically, in this particular chapter, what we are going to do exactly, we'll be trying to solve different types of questions which can be asked from the chapter mole concept, right? It's not only about the question solving. I'll be first of all giving you the concepts, right, which are used to solve the questions of different types of different patterns, right? So before starting this particular session, the ones who have just joined in, the ones who are new to the channel, let me quickly introduce myself. So people, my name is Wassim and I'm your chemistry master teacher right here on this Vedantu and NEET channel as well, okay? Well, the ones who have not liked the video yet, please do like the video, share the video with friends, do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this Vedantu and NEET channel, right? So do like the video, share the video with friends, and do subscribe to the channel as well, okay? Perfect. Let me quickly know in the chats if all of you are super excited about this particular session as well, my dear people, right? Let me quickly know. I'm doing great, guys. Thank you. Let me quickly know in the chats if all of you are super duper excited about this particular session as well. Yeah? Right, people? Should we get going? Perfect. So let's get going. Let's get started with the first question which is on your screen. It's a very common question, my dear people, based on one simple concept, right? Let me show you how these sort of questions are to be solved, right? Have a look exactly what the question says. As per the question, my dear people, magnesium has got three isotopes, which are Mg24, Mg25 and Mg26, right? The percentage abundance of Mg24 is 79. Average atomic mass of magnesium is 24.31. We need to calculate the percentage abundance of Mg25 and Mg26, right? That's the question which is on your screen. Let me first of all tell you how this sort of a question is to be solved, what is going to be the concept which is going to be involved in this particular question. Have a look. For example, people, let's say you have got the element X, right? Let's say you have got the element X. I'm assuming this element has got three different isotopes, right? That means this element has got three atoms which have got same atomic number, which I'm representing with Z, and different mass numbers. This is M1, this is M2, and this is M3. So basically, I've taken an element X. It has got three atoms which have got same atomic number but different mass numbers. So I should be calling these three atoms as isotopes of this particular element X, right? Let me tell you, whenever the element has isotopes, we always calculate average atomic mass for that particular element, right? And in order to calculate the average atomic mass, what do we need exactly? We need the percentage abundances of its isotopes, right? I'm assuming the percentage abundance of this isotope as A, the percentage abundance of this isotope as B, and percentage abundance of this particular isotope as C. Once you get the percentage abundance of all these isotopes, then you're going to make a simple formula, my dear people. That's going to be M1 multiplied by A plus M2 multiplied by B plus M3 multiplied by C divided by A plus B plus C. So the result which you'll be using to calculate average atomic mass of an element which has got isotopes is going to be M1A plus M2B plus M3C divided by A plus B plus C, right? Let me tell you one more thing. Do remember the sum of percentage abundances of all the isotopes. The sum of percentage abundance of all the isotopes of a particular element, that's always equal to 100, right? This is the concept which you'll be using here to solve the equation. Now we will have a look exactly how am I going to tackle this sort of equation. Understand properly. I'm going to do it slowly, right? Step by step we are going to do it. See, as per the equation is concerned, we have got magnesium. As per the equation, it has got some three isotopes. One is Mg24, another one is Mg25, another one is Mg26. These are the three isotopes of the element magnesium, right? Well, as per the equation, the percentage abundance of Mg24 is given to us as 79, right? And at the same time, the average atomic mass of magnesium is also given to us as 24.31 AMU, right? What do we need to calculate exactly? We need to calculate the percentage abundances of these two isotopes, right? Now we will have a look. See, how do I do it? First thing, if the percentage abundance of Mg24 is 79, right? Can I say the percentage abundances of these two isotopes combinedly is going to be 21? As simple as that. If this is 79, the percentage abundances of these two isotopes in combined form is simply going to be 21%. And I'm assuming, let's assume that X be the percentage abundance of Mg25. That means the percentage abundance of Mg26 is simply going to be 21 minus X%. As simple as that, right? So I assumed the percentage abundance of Mg25 is X. So this is simply going to be 21 minus X. Why is that? Because I told you in the beginning itself, the sum of percentage abundances of all the isotopes of a particular element, that's always equal to 100, right? Now people, can I say this is basically the value of M1 and this is the value of M2 and this is the value of M3, right? So I'll be using a quick result which I gave you a few minutes back. And what is that result? I told you a few minutes back, MAV, average atomic mass, is going to be M1A plus M2B plus M3C divided by A plus B plus C, right? As per the equation, the average atomic mass of magnesium is given to us as 24.31. M1 is 24 and A is 79, right? M2 is 25 and B is X plus M3 is 26 and C is 21 minus X. Divided by A plus B plus C is always going to be 100. And what is this A, B and C? A, B and C is basically the percentage abundances of these isotopes respectively, right? If you look at this particular equation, my dear people, can I say you just got one equation which contains one variable. And what is the variable? Variable is X, right? And I'm damn sure you can easily solve this equation now and get the value of X. And whatever value of X you get, that is going to be basically the percentage abundance of Mg25. And once you get X, it's going to be 21 minus X, which is going to be the percentage abundance of Mg26. I'm sure it's clear to everyone, right? So let me show you the final answer after solving the equation. After solving the equation, X value is coming out to be 11%, right? And the percentage abundance of Mg26 comes out to be 21 minus X. That means 21 minus 11, which comes out to be 10%. As simple as that, right? Yes. Let me quickly know in the chats if you can solve the questions based on this average atomic mass concept. Let me know fast in the chats. I'm looking at your chats only. Let me know in the chats if you got the concept properly. Yeah? Perfect, guys. So this sort of question, I'm sure you can easily solve from now onwards, okay? All right, one very, very simple and basic question. Calculate the number of ions in 0.1 moles of AlCl3, right? So as per the question, my dear people, have a look exactly. We have got 0.1 moles of AlCl3, right? Yes. So let me write it over here. The number of moles of AlCl3 which are given to us is equal to 0.1, right? For AlCl3, have a look. For AlCl3, the number of moles are given, right? Perfect. Now people, if I ask you how many formula units of AlCl3 will be there, right? Or instead of formula units, you can write molecules as well. Number of molecules of AlCl3. How do you convert moles into molecules? You just need to multiply moles with Avogadro's number. So these many molecules we have, these many formula units of AlCl3 we have, right? Now people, if I ask you one AlCl3, how many ions it contains? It contains one Al tripositive and 3 Cl negatives, right? It contains one Al tripositive and 3 Cl negatives. So can I say one AlCl3 contains total 4 ions, right? I'll say one AlCl3 contains total 4 ions. But do I have only one AlCl3 over here? No. I've got 0.1 NaAlCl3s. If one AlCl3 contains 4 ions, so can I say 0.1 NaAlCl3 will be containing 4 multiplied by 0.1 Na ions in total, which comes out to be 0.4 Na ions. So basically you got to know there will be total 0.4 Na ions present in 0.1 mole of AlCl3. As simple as that, right? Can you quickly let me know in the chats if it is clear to everyone? Perfect, guys. Good job. All right, I'm sure you can solve these sort of questions from now onwards. Simple. Whenever you need to calculate electrons, whenever you need to calculate ions, whenever you need to calculate atoms, first thing you'll be doing, you'll be converting moles into molecules. Then from molecules, you can easily calculate atoms, electrons, protons, neutrons, ions, etc., etc. Right? Okay. This is one more question, my dear people, and see exactly how do I solve this sort of a question. This question will make sure that your one concept gets clear from the average molar mass of the gaseous mixture. See guys what it means. First thing, before solving this particular question, let me give you the concept over here, right? See guys, let's say I've got two gases present in the container which are chemically non-reacting. I'm assuming I've got two gases present in the container, gas 1 and gas 2. I'm assuming these two gases are basically chemically non-reacting, right? These are chemically non-reacting gases which we have in the container right now, okay? Now, do remember, whenever you'll be having two or more than two chemically non-reacting gases in the container, you can clearly say that you have got a gaseous mixture present in the container, right? And let me tell you, for the gaseous mixture, we define a new term that's called as average molar mass. So average molar mass is first of all defined for a gaseous mixture, right? Now, how do we calculate this average molar mass of the gaseous mixture? There are few results which I would want you guys to remember to calculate average molar mass of gaseous mixture, right? Just give me a second, guys. Just give me a second. Just give me a second, guys. Just give me a second. Okay. So basically you have got two chemically non-reacting gases present in the container, right? So I can clearly say I have got a gaseous mixture in the container. So for the gaseous mixture, what do we do exactly? We calculate the average molar mass of the gaseous mixture. And how do I calculate this average molar mass of this particular gaseous mixture? There are few results which I would want you guys to remember. First result, average molar mass of this gaseous mixture is going to be equal to W1 plus W2 divided by N1 plus N2. W1 means the mass of gas 1 in the container. W2 means the mass of gas 2 in the container. Similarly, N1 means the number of moles of gas 1 in the container, and N2 means the number of moles of gas 2 in the container, right? This is the first result which I would want you guys to remember. Number 2, the second result. Second result is M1 multiplied by N1 plus M2 multiplied by N2 divided by N1 plus N2. M1, M2, these are the molar masses of these gases. N1, N2, these are the moles of these gases present in the container, right? Yes. Now people, there is one more result which I would want you guys to remember. That's going to be M1 multiplied by V1 plus M2 multiplied by V2 divided by V1 plus V2. This result to calculate the average molar mass of the gaseous mixture is only valid when the pressure and temperature of the gaseous mixture is kept fixed, is kept constant, right? One more result I would want you to know, that is M1 multiplied by Chi1, M2 multiplied by Chi2. This is one more result by means of which you can calculate the average molar mass of the gaseous mixture. M1, M2, these are the molar masses of these two gases. And this Chi1 and Chi2, these are the mole fractions of these two gases present in the container. Chi1, Chi2 are the mole fractions of gas 1 and gas 2 in the container. So I can give you one more result which I would want you guys to remember. M1 multiplied by mole percent of 1 divided by 100 plus M2 multiplied by mole percent of 2 divided by 100. Right? This is one more result which I would want you guys to remember to calculate the average molar mass of the gaseous mixture. So these are basically different results which we have to calculate the average molar mass of the gaseous mixture. So I'm sure you got to know what are the different results to calculate the average molar mass of the gaseous mixture. Now let's try to solve this particular question. See what the question is exactly. Have a look. Have a look exactly, guys. Basically, it's mentioned in the question at 27 degrees centigrade and 1 atm pressure. So first thing, the pressure and temperature of the gaseous mixture is kept constant, right? And there is only one result which we can use to calculate the average molar mass of the gaseous mixture when its pressure and temperature is constant, right? So one thing that definitely would be right now in your mind, right? Yes? Now, so basically, in this particular container, we have got two gases. One is O2 gas and one is SO2 gas. These are the two gases present in this particular container, right? Perfect. Now guys, have a look. Let me call this O2 as gas 1. Let me call this SO2 as gas 2. Right? I'm just making it in the simplified form so that you can understand it properly. I'm calling this as gas 1, I'm calling this as gas 2. If I ask you first of all, what is the molar mass of gas 1? You'll say 32 grams per mole. If I ask you what is the molar mass of gas 2, you'll clearly say it's 64 grams per mole, right? Now people, since this gaseous mixture, it's present at constant pressure and temperature, right? Yes. And let me tell you, the volume ratio of the gases is given to us. It's given to us as 2:1. The volume ratio of the gas is given to us as 2:1. So I can clearly call this as V1. I can take this as V2. I can take this as V2, right? Now, as per the question, calculate the total moles present in 20 grams of the mixture. So basically, mass of the whole mixture is given to us as 20 grams. I need to calculate the total moles present in the gaseous mixture. So I can say total moles present in the gaseous mixture is going to be basically equal to mass of the gaseous mixture divided by molar mass of gaseous mixture, which we call as average molar mass, right? Perfect. If I ask you, what is the mass of the gaseous mixture? That's given to us as 20 grams divided by average molar mass of the gaseous mixture I need to calculate, right? Now first thing, which formula do I need to use to calculate the average molar mass of the gaseous mixture? Since pressure and temperature of this particular mixture is constant, right? So I'll be using only one formula to calculate the average molar mass of the gaseous mixture. That's going to be like this. MAV is equal to M1V1 plus M2V2 divided by V1 plus V2. As simple as that, right? Now people, what is the value of M1? M1 value is 32. What is the value of V1? That's 2. Plus M2 value is 64, V2 value is 1, divided by V1 plus V2 is 3. The value comes out to be 128 divided by 3 grams per mole. This is the average molar mass of the gaseous mixture which we calculated, right? Now people, if you got the average molar mass of the gaseous mixture, you can calculate the total moles present in the mixture, which is basically going to be equal to mass of the mixture divided by molar mass of the mixture, which is 128 by 3. 3 comes up. So 60 divided by 128. So 60 divided by 128 is going to be the correct answer of this particular question. You guys can let me know in the chats if it is clear to every single guy. Let me know in the chats, my dear people, if this concept is clear to everyone. Let me know if you can solve these sort of questions easily from now onwards. Yeah? Let me know fast. Perfect, guys. So let me quickly move on to one more particular question. See, this is a question based on stoichiometry, right? How do we solve? This is a very simple and basic question, guys. Okay? So let me show you first of all what is the concept involved in this one and how do we solve these sort of questions. Have a look properly what I'm going to do. See, first of all, if I'll be taking a hydrocarbon CXHY, if I do its combustion, it will always lead to the formation of carbon dioxide, and with this carbon dioxide, you'll be writing water as well, right? Now, let me tell you the first thing of balancing this combustion reaction. How do we balance it? See, this is X over here. Just keep this X right here. This is Y over here. Keep Y by 2 over here and make the stoichiometric coefficient of O2 as X plus Y divided by 4. The reaction will be automatically balanced, right? Now say exactly how am I going to solve the question. See guys, as per the question, I'm doing the combustion of octane, C8H18. This is octane basically. I'm going to do its combustion. So I'll make it to react with what? oxygen, excess of oxygen, it will lead to the formation of carbon dioxide, and with this carbon dioxide you'll be writing water as well, right? This is first of all the reaction that's going to happen over here. The first thing, whenever I try to use the stoichiometry, do remember, first thing which you need to do is to balance the reaction. Is this reaction balanced right now? No, it's not balanced at all. So first thing, I'm going to balance this particular reaction. Let's try to balance it. This is 8, let's make it as 8 times. This is 18, let's make this as 9 times. And this one is going to be x plus y by 4, which makes it 25 divided by 2 times, right? The first thing which I did to balance the reaction. Yeah? Now, as per the question, we are doing the combustion of 570 grams of octane, right? And we need to calculate what will be the volume of carbon dioxide which will be getting liberated when we do the combustion of 570 grams of octane, right? The first thing which I'll be doing, my dear people, I'll be calculating the number of moles of octane. I'll be calculating the number of moles of octane, which is going to be equal to given mass of octane, 570 grams, divided by molar mass of octane will come out to be 114. The value comes out to be 5. So basically, as per the question, I need to do the combustion of 5 moles of octane. And then I'll see what will be the volume of carbon dioxide liberated after the combustion of 5 moles of octane, right? That's something which I need to do. See what I'll be doing. Stoichiometric coefficient of octane right here is 1, and stoichiometric coefficient of carbon dioxide over here is 8. Can I say something like this? Can I say 1 mole of octane produces 8 moles of carbon dioxide? As simple as that. If 1 mole of octane produces 8 moles of carbon dioxide, can I say 5 moles of octane when undergoes combustion, they'll produce 8 multiplied by 5, that is 40 moles of carbon dioxide, right? So you got to know exactly the number of moles of carbon dioxide which are being liberated, right? When we do the combustion of 5 moles of octane. And how many moles of carbon dioxide are being liberated? 40 moles, right? Since you got to know the moles of carbon dioxide liberated, but as per the question, you need to calculate the volume of carbon dioxide liberated at STP. Right? So what I would want you guys to do, I would want you guys to convert the moles of carbon dioxide into volume at STP. And how do we do that? Just multiply these moles by the 22.4, right? The value comes out to be 896 liters. So you got to know exactly 896 liters of carbon dioxide is being liberated when we do the combustion of 570 grams of octane, when we do the combustion of 5 moles of octane. I'm sure you can clearly solve these sort of questions from now onwards, right? Just let me know fast in the chats if it is clear to everyone. Let me know fast in the chats, my dear people, if it's clear to everyone. Let me know fast. Perfect. Absolutely, guys. Wonderful. Perfectly done. Let's move on to one more question. This is one more question, and let me show you quickly how do we tackle this sort of a question. Have a look, guys. The question is again simple. There is a small concept involved here. See, calculate the number of moles of oxygen atoms present in 3.2 grams of Na2SO4.2 times water, right? This is the question on the screen. Let's try to solve this. First thing, I will be calculating the number of moles of Na2SO4.2 times water which are given to us. Number of moles of this particular substance will be equal to mass of the substance, which is 3.2 grams, divided by molar mass of the substance, which is 178. So these many moles of Na2SO4.2 times water which we have, right? Yes. I converted the given quantity into number of moles first of all, right? Now people, if I write something like this, 1 mole of Na2SO4.2 times water. Can you let me know how many moles of oxygen atoms are present in 1 mole of Na2SO4.2 times water? Check it. Check it, my dear people. Mr. Fazan, you can go to some other channel, bro. This is not your channel, I believe, right? Don't try to distract the people. They come here to study, not to chit-chat, right? You can go to some other channel, not here. Okay. 1 mole of Na2SO4.2 times water. So it's going to be 4 plus 2 comes out to be 6, right? So it contains 6 moles of oxygen atoms. 6 moles of oxygen atoms, right? 1 mole of Na2SO4.2 times water contains 6 moles of oxygen atoms. So if 1 mole of this substance contains 6 moles of oxygen atoms, So can I say 3.2 divided by 178 moles of this particular substance will be containing 6 multiplied by 3.2 divided by 178 moles of oxygen atoms, right? As simple as that. Perfect. Just do a bit of calculation right here and get the answer. That's something which you are supposed to calculate. See, 1 mole of this substance contains 6 moles of oxygen atoms. So these many moles of the substance will contain these many moles of oxygen atoms. That's something which you are supposed to calculate, right? Perfect. Yes. Perfect, guys. Absolutely. Wonderful. So final answer of this particular question will come out to be 0.107. That's all. That's all, my dear people. Okay. This is one more question which you need to solve, my dear people. And the question is based on the limiting reagent concept, right? So if I ask you what is limiting reagent actually? Limiting reagent is that reactant which gets completely consumed first in the reaction, right? That reactant which gets completely consumed during the reaction, that too first, is something which we call as limiting reagent exactly. And how do we solve exactly the questions which are based on the limiting reagent? Have a look at exactly how am I going to solve this one. See, guys. First thing, the reaction that's given to me is 3 times BaCl2 plus 2 times Na3PO4 whole twice, sorry, Na3PO4. It gives Ba3PO4 whole twice, and then you have got 6 times NaCl as well. This is the reaction that's given to us, right? This is a particular reaction. First thing, my dear people, whenever you try to solve the question based on the limiting reagent concept, you always try to balance the reaction first. Since the reaction is already given in the balanced form, right? So you need not to balance it again, it's already in the balanced form, right? Now, as per the question, my dear people, have a look. At time t is equal to 0, initially we have got 0.1 moles of BaCl2 and we have got 0.3 moles of Na3PO4, right? 0.1 moles of BaCl2 and 0.3 moles of Na3PO4. Perfect. At time t is equal to 0, the reaction wouldn't have started yet. So the number of moles of product formed is going to be 0, right? Because the reaction has not started yet. Now, people, you need to identify which one among the two is going to be the limiting reagent. And how do you identify exactly the limiting reagent? You just need to do one thing. You just need to divide the given number of moles by the respective stoichiometric coefficients. You just need to divide the given number of moles by the respective stoichiometric coefficients. So you'll be dividing this 0.1 by its stoichiometric coefficient, 0.3 by its stoichiometric coefficient. This value comes out to be 0.033 and this value comes out to be 0.15. Which one is the lesser value among the two? This one is the lesser value among the two, right? So this particular one is going to be my limiting reagent over here, right? So you identified first of all, BaCl2 is your limiting reagent. If BaCl2 is the limiting reagent, my dear people, I'll say BaCl2 would have got completely consumed in the reaction. So there'll be 0 moles of BaCl2 left at the end of the reaction. Now, entire product formation is completely decided by the limiting reagent, right? And how come? I'll be using the stoichiometry now. Can I say, as per the stoichiometry, 3 moles of BaCl2, 3 moles of limiting reagent gives 1 mole of Ba3PO4 whole twice? Absolutely. 3 moles are giving me 1 mole, right? So 1 mole of BaCl2 will give me 1 by 3 moles of this, right? So 0.1 moles will give me 1 by 3 multiplied by 0.1, which is going to be exactly 0.1 by 3, which is going to be 0.033 moles. So these are basically the number of moles of Ba3PO4 whole twice, which gets formed at the end of the reaction, right? These are the number of moles of Ba3PO4 whole twice, which gets formed at the end of the reaction. Right, people? Now, since you got the moles of Ba3PO4 whole twice formed, you just need to multiply this term by the molar mass of this substance. You'll be getting the mass of the Ba3PO4 whole twice which gets formed. Let me show you the final answer, my dear people. Have a look. Moles 0.033 multiplied by molar mass of the substance. Molar mass of the substance is around 601. Then you'll be getting the mass of the substance, mass of the Ba3PO4 whole twice which gets formed at the end of the reaction, right? I'm sure it's clear to everyone. Guys, there's a mistake over here. You need to multiply 601 with 0.033, right? Okay? You need to multiply it. Anyways, this is one more similar sort of question, and I'm sure you can easily solve this one. It's a similar sort of question, my dear people. Yes, Arshil, molar mass of these substances will be given to you, right? Yes. This is the similar type of question, my dear people, right? The question is again based on the limiting region. I'm sure you can easily solve it, right? So I'm not going to solve this particular question. You can do it on your own. You can take this as the homework. It's again the simple question based on the same concept. Identify the limiting region, right? Then do the product formation as per the limiting region. That's all. Yeah. Okay. Then we have got other different set of questions as well, right? Which are based on percentage yield, percentage purity, and percentage composition, right? Let me first of all show you how do we calculate percentage yield of the reaction. Just remember one formula. Percentage yield of the reaction is always equal to experimental amount, which will be most of the times given to you as per the equation, expected amount, which we'll be calculating with the help of stoichiometry, multiplied by 100. And how do we solve the question based on this one? Have a look. This one simple question which I've taken into consideration right here. I need to calculate percentage yield of this reaction. I need to calculate percentage yield of this reaction. Have a look. See guys, as I told you, how do we calculate percentage yield? It's going to be experimental amount divided by expected amount multiplied by 100. That's all. See guys, as per the equation, 1.12 grams of calcium oxide is reacted with excess of HCl and 1.776 grams of CaCl2 is formed, right? So this is something which is given to me as per the question. So this has been observed experimentally that when we make 1.12 grams of calcium oxide to react with HCl, actually in the lab it has been observed that 1.776 grams of CaCl2 is formed. So this is something which I call as experimental amount. This is something which I call as experimental amount of CaCl2, right? Yes, experimental amount of CaCl2. In order to calculate the percentage yield, I will be calculating the expected amount first with the help of stoichiometry. Then I'll be dividing the two, multiply with 100, get the answer. Now guys, have a look exactly how do I get the expected amount of CaCl2. Have a look exactly what am I going to do. If I ask you what is the molar mass of calcium oxide, molar mass of calcium oxide is going to be 40 plus 16, that means 56 grams. This is the molar mass of calcium oxide, or you can say this is the mass of 1 mole of calcium oxide. 1 mole of calcium oxide, right? Similarly guys, if you talk about CaCl2, molar mass of CaCl2 is 111 grams, or you can say 111 grams is the mass of 1 mole of CaCl2, right? Now have a look exactly what I'll be doing. Can I say 56 grams of CaO should give 111 grams of CaCl2 as per stoichiometry? So 1 gram of CaO should produce 111 divided by 56 grams of CaCl2, right? So I can say 1.12 grams. 1.12 grams of CaO should produce 111 divided by 56 multiplied by 1.12 grams of CaCl2, right? So this is basically the mass of CaCl2 which should have got formed as per the stoichiometry. This is the mass of CaCl2 which should have got formed as per the stoichiometry. So this is basically the expected amount. This is something which I was expecting as per the stoichiometry, that this much amount of CaCl2 should have got formed at the end of the reaction. But actually how much is getting formed? This much is getting formed. This is my expected amount. This is my experimental amount. So in order to calculate the percentage yield of the reaction, I'll be writing experimental amount 1.776 divided by expected amount. Well, I think this value will approximately come out to be 2.2, right? 2.2 multiplied by 100. When you solve this term, the value comes out to be approximately as 80%. So 80% is basically the percentage yield of this particular reaction which was given to us, right? Let me quickly know in the chats, my dear people, if you can easily solve these sort of questions from now onwards, right? Yes, 2.2 and this is the final answer, 80%. Yeah? Can you quickly let me know in the chats if every single thing is clear till here? Then only I can move on to the next type of question. Perfect, guys. This is one more similar sort of question, and let's exactly get to know how to tackle these sort of questions. See, guys. First thing, have a look. I'll be writing a result over here. What is that? I'll be writing percentage of an element in a given compound. Percentage of an element in a given compound. Do remember, it's always equal mass of the element in 1 mole of compound divided by molar mass of the compound multiplied by 100. This is one direct result which I would want you guys to remember. Okay? Percentage of an element in a given compound. Whenever you need to calculate the percentage of an element in a given compound by mass, it's always equal to mass of the element in 1 mole of compound divided by molar mass of the compound multiplied by 100. That is the result which you'll be using. And see exactly how it's to be solved. See, as per the question, you have got a compound insulin. You have got a compound insulin, right? As per the question, the percentage of sulfur in insulin is equal to 3.2, right? It's given in the question. Percentage of sulfur in insulin is given as 3.2, right? So this clearly indicates in insulin there will be sulfur. I need to calculate the minimum molar mass of insulin. I'll simply write a result. I'll write percentage of sulfur in insulin is going to be equal to mass of sulfur in insulin, mass of sulfur in 1 mole of insulin divided by molar mass of insulin multiplied by 100, right? Multiplied by 100. This is the simple result which I'll be using over here, right? See, percentage of sulfur in insulin is going to be equal to mass of sulfur in 1 mole of insulin divided by molar mass of insulin multiplied by 100. But people, do you know in 1 mole of insulin how many sulfur atoms will be there? No, right? I'm assuming in insulin, let's say there are some X sulfur atoms present there, right? So I'll be writing something like this. Percentage of sulfur in insulin is given to us as 3.2. Since I need to calculate the minimum molar mass of insulin, molar mass of insulin as per this question can be minimum only if there will be only 1 mole of sulfur in 1 mole of insulin, right? Simple. Molar mass of insulin can only be minimum if there will be only 1 mole of sulfur in 1 mole of insulin. So I'm assuming in the insulin, I'm assuming there is 1 mole of sulfur present in 1 mole of insulin, right? And if I talk about the mass of 1 mole of sulfur, is simply going to be 32 grams, which is the molar mass of insulin, which is the molar mass of sulfur, right? Divided by. Now, I won't be writing only the molar mass. I'll be writing the minimum molar mass of insulin. Multiplied by what? Multiplied by 100, right? So the question is almost done. So from here, you'll be calculating the minimum molar mass of insulin, and it's going to come exactly as 1000 grams per mole. That's all. Option C is the one that's correct, right? Simple and basic. I'm sure you can easily solve these sort of questions. Again, once again, I'm telling you, my dear people, percentage of an element in a compound is always equal to mass of the element in 1 mole of the compound divided by molar mass of the compound multiplied by 100. So since you need to calculate the minimum molar mass of insulin, in order to calculate the minimum molar mass of insulin, I'll assume that in 1 mole of insulin, there'll be only 1 mole of sulfur. And 1 mole of sulfur has got the mass of 32 divided by minimum molar mass multiplied by 100. It gives you the minimum molar mass of insulin as 1000 grams per mole. I'm sure you can easily solve this sort of equation again from now onwards, right? Yes. Now, people, this is one more different type of question which is based on percentage purity, right? Let's have a look exactly how these sort of questions are to be tackled. See guys, first thing, let me tell you one important thing. In a chemical reaction, only a pure substance participates. In a chemical reaction, only a pure substance participates. Impurity does not participate in the reaction. In the reaction, only the pure substance participates. Impurity does not participate in the chemical reaction. Do remember this, number one. Number two, the reaction that's given to me is something like this. H2SO4 plus 2 times NaOH. As per the question, it's giving me Na2SO4 plus 2 times H2 plus 2 times H2. This is the reaction that's given to us. Have a look exactly, my dear people, how to solve this. As far as this question is concerned, 5 grams of H2SO4 sample. 5 grams of H2SO4 sample. So basically you have got a sample of H2SO4, right? You do not know what is the pure mass of H2SO4 in the sample. You do not know that. So basically this is the impure mass of the sample. This is the impure mass of the sample. Let me call this as impure mass of H2SO4 sample. You have right now no idea what is the pure mass of H2SO4 in this sample, right? Exactly requires 4 grams of NaOH. Exactly requires 4 grams of NaOH for complete neutralization. calculate the percentage purity. We need to calculate the percentage purity of H2SO4 in the sample. Understand? How am I going to do this? If I ask you what is the molar mass of H2SO4, you'll clearly say it's 98 grams. If I ask you what is the molar mass of NaOH, it's 40 grams per mole, right? But our 2 moles, so it's going to be 80 grams. So I'll say mass of 1 mole of H2SO4 is 98 grams, mass of 2 moles of NaOH is 80 grams. If I use a stoichiometry like this, can I say 80 grams of NaOH, as per the stoichiometry is concerned, 80 grams of NaOH reacts with 98 grams of H2SO4, right? Simple. 80 grams of NaOH reacts with 98 grams of H2SO4. So can I clearly say 1 gram of NaOH will be reacting with 98 divided by 80 grams of H2SO4, right? So 4 grams of NaOH will be reacting with 98 divided by 80 multiplied by 4, and this value comes out to be 4.9 grams of H2SO4. So people, you exactly got to know this is basically the mass of H2SO4 which actually has participated in the reaction. This is the mass of H2SO4 which has participated in the reaction. You got to know exactly 4 grams of your NaOH would have reacted with 4.9 grams of H2SO4. So this is basically that mass of H2SO4 which has participated in the reaction, right? And that mass of the substance which participates in the reaction, that's something which we call as pure mass. So this is basically the pure mass of H2SO4 which is present in 5 grams of impure sample. What do I need to calculate? Percentage purity. Percentage purity of H2SO4 in the sample is equal. Do remember, mass of the pure H2SO4, 4.9 grams, divided by mass of impure sample, 5 grams, multiplied by 100. When you solve it, the value comes out to be 98%. So 98% is the correct answer of this particular equation. Let me know in the chats if everything seems clear to you. Let me know in the chats, my dear people, if everything seems clear to you. And if you have not liked the video, please do like the video, share the video with friends, and do subscribe to the channel as well. Yeah? I'm sure you're remembering how do we solve these sort of questions, right? Okay. Different concentration terms, starting with mass percent of solute, or you call it as weight by weight percent of solute. How do we calculate it? It is always equal to mass of solute in grams divided by mass of solution in grams multiplied by 100. Similarly, weight by volume percent of solute. How do we get it? Mass of solute in grams divided by volume of solution in milliliters multiplied by 100. Be careful with these units, my dear people. Be careful with these units. Volume by volume percent of solute. Volume of solute in ml divided by volume of solution in milliliters multiplied by 100, right? Similarly, molarity. How do we calculate molarity? There are many results. Number of moles of solute divided by volume of solution in liters, right? Then you can convert it in another form. This one more, a formula, my dear people, which you are going to remember directly. Molarity is equal to 10 multiplied by density of solution multiplied by weight percent of solute divided by molar mass of solute, right? Similarly, molality, number of moles of solute divided by mass of solvent in kg, right? And these are some direct results which relate molality with mole fraction of solute. This is molality, this is mole fraction of solute, right? Similarly, this is the result which relates molality with molarity. Now let's have a look how these sort of things are to be solved. I mean, how these sort of formulas are to be used in the equations. But before that, have a look. Formula to calculate mole fraction, I'm sure you all must be knowing this, and formulas to calculate ppm of solute and ppb of solute. 2 represents solute, right? 2 represents solute, 1 represents solvent. Parts per million of solute is equal to weight by weight percent of solute multiplied by 10 raised power 4, and parts per billion of solute is equal to W by W percent of solute multiplied by 10 raised power 7. Do remember these results directly, right? Well, after remembering these results, let's try to analyze and let's try to use these results in the questions directly, right? By solving the equations, all these things will get clear to you. Have a look what I said exactly. This is one of the famous questions, my dear people, from the molarity topic, right? And one of the common questions, this has been asked once in JEE as well. I don't remember the year, but this was asked. As per the question, you are dissolving 120 grams of urea. You are dissolving 120 grams of urea in 1000 grams of water. So basically, solute is urea, whose mass is given to us as 120 grams, and solvent is water, whose mass is given to us as 1000 grams, right? Gave a solution of density. When you are mixing the two, the solution which you are getting, its density is given to us as 1.15 grams per ml. What do I need to calculate? I need to calculate molarity of the solution, right? I need to calculate molarity of the solution. How do I do it? Simple. There is one result which I would want you guys to remember. Molarity of the solution is equal to mass of solute in grams multiplied by 1000 divided by molar mass of solute multiplied by volume of solution in milliliters. This is one of the results by means of which you can calculate molarity of the solution, right? Now people have a look. Mass of solute is given to me, multiplied with 1000. Molar mass of urea. Do remember, molar mass of urea is 60 grams per mole. NH2CONH2, molar mass of urea is 60 grams per mole, right? But volume of solution is not given to me. So I need to calculate volume of solution by somehow, right? And how do I calculate the volume of solution? Have a look. For that purpose, density of solution is given to me. Can I say density of solution is nothing? It is mass of solution in grams divided by volume of solution in ml is equal to 1.15. So you can write volume of solution is equal to mass of solution in grams divided by density of solution in grams per ml is equal to mass of solution, as per the question, is going to be mass of solute plus mass of solvent. So 1000 plus 120 comes out to be 1120 grams divided by 1.15. When you solve this value comes out to be 973 milliliters. This is the volume of solution which we have. That's it. The question is done and dusted. Now calculate the molarity, which is equal to mass of solute, which is 120 grams multiplied by 1000. Molar mass of solute, 60 grams per mole. Volume of solution in ml, 973. The value approximately will come out to be 2.05. This is the molarity of the solution which we were supposed to calculate. I hope you exactly got to know how I solved this question. By using the density result, I calculated the volume of solution, and after getting the volume of solution in milliliters, I used it in this expression. Rest all the terms were given to me. I calculated the molarity of the solution. Right, people? Perfect. One more question on the screen. One more question on the screen. Arshad, unit of molarity is moles per liter. Moles per liter is the unit of molarity, or you can call it as molar, which is represented by capital M. Yeah? Yes? Okay, this is one more question, my dear people. I'm just going to give you the hint of this particular question. Rest of the things you are going to do on your own. I'm just going to give you the hint. Molarity of the solution is given to us. Density of the solution is given to us. Molar mass of solute, you know, molar mass of NaOH, that's 40 grams per mole. First thing I need to calculate molarity. There is one result which I gave you a few minutes back. Molality is equal to 1000 multiplied by molarity of solution divided by 1000 multiplied by density of solution minus molarity multiplied by molar mass of solute. You need to calculate molality. Capital M, molarity is given to you as 1.5. Density of solution given to you. Molarity given to you. Molar mass of solute, molar mass of NaOH, 40 grams per mole. Put all the things into this expression, get the value of molality. That's all. That's all, right? Second, weight by weight percent of solute. You can easily do this as well, right? You can easily calculate this as well. Few minutes back, I gave you one relation. Molarity is equal to 10 multiplied by density of solution multiplied by weight percent of solute divided by molar mass of solute. This is one of the results which I gave you a few minutes back, right? Molarity of the solution given to us, density of solution given to us, molar mass of solute, you know, 40 grams per mole. So you can calculate weight by weight percent of solute, right? Once you got the weight by weight percent of solute, you can calculate weight by volume percent of solute as well. Do remember from now onwards directly, weight by volume percent of solute is nothing. It is just weight by weight percent of solute multiplied by density of solution. Do remember these results directly so that you cannot waste a lot of time on these questions, right? And then you can calculate mole fraction of solute as well. I already gave you one result. Molality is equal to mole fraction of solute multiplied by 1000 divided by 1 minus mole fraction of solute multiplied by molar mass of solvent, right? All these results are given to you. You just need to calculate mole fraction. M you know, Chi2 value you know, right? Sorry, Chi2 you need to calculate. Molar mass of solvent. Solvent I'm assuming is water over here. So molar mass of water, you know, that's 18 grams per mole. So from here you can calculate the mole fraction of solute. That's it, right? I'm sure you can easily solve these sort of questions from now onwards, right, people? Okay. This is one more simple question based on the dilution, right? Based on the dilution. How much water, it's a very common question again. How much water shall be added to 200 ml of 2 molar? See guys, this is the initial volume of solution that's given to me. This is the initial molarity of the solution that's given to me, right? This is the final molarity of the solution which is given to me. I first of all need to calculate final volume. So I'll be simply using the dilution formula. As far as your dilution formula is concerned, you know M1V1 is nothing, it is just M2V2. Well, M1 value is given to me as 2, V1 value is 200 ml, M2 value is given to me as 0.2. So from here you'll be calculating the final volume of the solution. So final volume of the solution, when you solve it, it will come out to be 2000 milliliters. This is the final volume of the solution. But do I need to calculate the final volume of solution or volume of solvent added? I need to calculate the volume of solvent added, volume of water added. So volume of water added is going to be final volume minus initial volume, 2000 minus 200 comes out to be 1800 milliliters. So this is basically the volume of water which has been added. Then only 200 ml of 2 molar solution becomes 0.2 molar, right? Perfect. I'm sure you can again solve these sort of questions from now onwards, that too easily, right? Perfect. This is one more question, guys. Let's have a look exactly how this sort of a question is to be solved. The volume of water that has to be added to a mixture of 250 ml of 0.6 molar HCl and 750 ml of 0.2 molar HCl to obtain 0.25 molar of HCl solution. It's simple, guys. You can clearly solve this one. See. So basically I've got a mixture of two solutions. This is the volume of one solution, molarity of the first solution, volume of second solution, molarity of second solution. So you are basically adding these two solutions up, and at the same time, during the addition of these solutions, during the mixing of these solutions, you are basically adding water as well, right? So I'll simply use one concept. I'll use the concept number of millimoles of solute. Number of millimoles of solute before mixing must be equal to number of millimoles of solute after mixing. Number of millimoles of solute after mixing. How do we calculate millimoles? Molarity of the solution multiplied by volume of solution in ml. That gives you the number of millimoles, right? So how many moles of solute we have before mixing, right? See, this solution we have, its molarity you know, its volume you know. If you multiply these two things, you'll be getting the millimoles of solute present in this particular solution, which is 250 multiplied by 0.6. These are basically the millimoles of solute present in the first solution plus millimoles of solute present in the second solution, which is 750 multiplied by 0.2. These are the millimoles of solute present in the second solution, right? Then you're adding water as well, right? You're adding water as well. Well, the final solution which you get, its molarity, you know, that's 0.25. And what is going to be the final volume of solution? It's going to be 250 plus 750 plus, for example, V ml of water I've added. V ml of water I've added, for example, right? So we will have a look exactly. This is one equation which you have, which has got only one variable, that's V. What is V? V is the volume of water added. When you solve it, you get the volume of water added, which I was supposed to calculate, right? The final answer comes out to be 200. That's it, right? Yes? Exactly. Arshad, this is molarity of mixing concept, right? And people, this was the last question of the tonight's session, right? Or wait, before this, there is one more concept involved. Just a second. This is something which is based on the same thing, right? Molarity of dilution. You can solve it on your own. Empirical molecular formula, right? There are questions based on this as well. There are questions which are asked from this particular concept as well. There is only one thing which you need to remember in empirical molecular formula concept. See, guys, we have got basically a compound which contains three elements: potassium, chromium, oxygen. Their mass percentages are given to us. Their mass percentages are given to us. I need to calculate what? I need to calculate empirical formula. There is a simple procedure which you need to follow. First, divide all these mass percentages by their respective atomic weights. Atomic weight of potassium, 39. Atomic weight of chromium, 52. Atomic weight of oxygen, 16. Divide these mass percentages by their respective atomic weights. You'll be getting the atomic ratio. This is what we call as atomic ratio of potassium, atomic ratio of chromium, atomic ratio of oxygen, right? Now, see which one is the least term among all. This is the least term among all, 0.68. Divide all the things, divide all these atomic ratios with the least number, that is 0.68. So first thing, 0.68 by 0.68, 1. Again comes out to be 1. Then comes out to be 3.5. So you got the simplest ratio, 1 is to 3.5. But is it the simplest whole number ratio? This is not the simplest whole number ratio. So multiply throughout by 2. It becomes 2, it becomes 2, it becomes 7. So empirical formula is basically the simplest whole number ratio. So you got to know it's going to be K2, Cr2 and O7. That is the empirical formula of the compound, right? Okay, and this is the similar sort of question which you need to do on your own. Perfect? Right, guys, there's a similar sort of question which I'm giving you as the homework. Do let me know its answer in the chats, right? And before ending the session, quickly let me tell you, if you have not enrolled in this particular crash course batch, do get enrolled as soon as possible, because the batch is starting on Monday, coming Monday, right? And if you are not going to get enrolled till Sunday, let me tell you, its price is going to hike up. Its price is going to hike up. You're going to get the same crash course for around 7.5K, which right now you're getting in just 1800. Do get enrolled in this one as soon as possible if you have just started your preparation or if it is not up to the mark. Do get enrolled because it involves the whole syllabus completion, number one. Number two, it includes the test series as well. Test series is included here. Number three, live doubt solving will be there during the session. When you face any sort of difficulty in understanding the topic, you can ask your doubt to your master teachers, right? Then study material will be provided to you. Every single thing, whatever parameter is needed for NEET to get cracked or JEE to get cracked, you can definitely, you can cover up all these things, all the things in this particular crash course batch, right? The batch is starting on coming Monday, right? So quickly, I'll show you how to get enrolled, and it's my personal decision to get enrolled in this one, right? Because it's absolutely beneficial. If you want to improve your ranks in NEET and JEE, you can definitely get enrolled in this one. See guys, in order to get enrolled, you need to click on show more over here. This is the video which you guys are watching. Click on show more. After clicking on show more, over here there is a NEET crash course link and there is a JEE main crash course link. The choice is all yours to, whatever crash course you want to join in, you can do that. For example, you are going for NEET, click on this link. After clicking on this link, just click on buy course. After click on buy course, put your number, email ID on which you get the OTP and everything, and eventually you'll be getting enrolled into the NEET 2022 crash course batch, which is starting on Monday. So again, I'm telling you, this crash course batch, it involves the whole syllabus completion in all the subjects. If you want to go for NEET crash course, then physics, chemistry, biology, whole syllabus will be done, right? In just 120 sessions. Apart from that, session recordings will be provided to you till your NEET 2022 examination. Number three, no need to worry about the test series. No need to buy the test series from some other source. Test series is included here, right? Number four, during the session, if you face any sort of difficulty in understanding the topic, you can ask your doubt to your class teachers at that point of time. That is the fourth benefit of this particular one. So trust me, it's the one special crash course batch which is going to get launched on Monday on the actual Vedantu platform, right? For both JEE as well as NEET students. Good. So go get enrolled in it as soon as possible. Why is that? Why am I telling you that? Because from Monday, its price is again going to hike up. You are going to get the same crash course batch for 7.5K after Monday, right? So till Monday morning, you can get enrolled in this one for just 1800, right? And it includes every single thing. And the teachers who are going to train you in this particular batch, they are absolutely the masters of their subjects, who have actually produced the top all India ranks before, right? So with this, people, I'm going to take a leave. I'll see you guys tomorrow at the same time. Till then, you take care. Bye-bye. God bless you all. Love you all. And I'm sure you now enjoyed the session, right? Some things would have got cleared properly. And if you actually like the session, do let me know in the comment section of this particular video, right? See you tomorrow at the same time. Till then, you take care. Bye-bye. God bless you all and love you all. Bye.